So this lecture is for those folks who are not familiar with some of the terms that are used in Create ML, the basically metrics that are used to measure the good or how good the model is. So these terms are accuracy, recall, and precision that you saw when we were training a model. And there is another term that is used very commonly called F1 score. So for those who are not familiar with these terms, I am going to take a detour and try to explain some of these terms. If you are already familiar with these terms, feel free to skip this lecture. So when a data set is given to you, typically, let's consider an example of a binary classification where the output is either positive or negative. You can take an example of a spam email, whether the email is spam or not, or let's say take a case of fraud detection in a credit card, whether the particular application is fraud or not, or let's say whether the particular patient is sick or not, and the disease is very dangerous disease like COVID-19, or let's say you have a data set that could detect whether a person is terrorist or not, right? So the outcome is either positive or negative, and the data set that is given to you also has positive and negative samples, right? So here usually we very often we calculate accuracy, right? So accuracy represents how many results were matching with the predicted results were matching with the actual results, right? So let's define that term formally and let's understand why accuracy itself is not good enough metric to measure the how good the machine learning model is. So let's consider a data set which has two kinds of outputs, right? The actual output, either it could give negative or positive, okay? And the machine learning model will predict whether the outcome is actual negative or actual positive, right? So ideally we want the actual outputs to match with the predicted outputs, right? So for example, if the actual is predicting a sample to be negative, we want predict our ML model also to predict negative. So we want this number where it is called a true negative, where the predicted negative is matching with the actual negative. We want this number to be as high as possible. Similarly, we also want the positive outcomes, predicted outcomes, to match with actual positive outcomes. So we want this number also to be very high, and it's called true positive. Okay, so accuracy is formally defined as a ratio of true positive, which is in this particular case is this particular example, divided by true negative, which is 998, divided by total number of samples, which is 1000. And the accuracy in this case is found to be 99.9%. So you might say, hey, the model is working pretty well. It's giving me 99.9% of accuracy, right? So that may not be always true. Consider an example. Let's say when the model says positive, it's a case where a person is sick and he has a dangerous disease. Okay, that case is considered as a positive case. Now let's consider a case where a person who was misclassified as not having a model is predicted that he does not have a disease. Let's say one such person is detected. Okay, so in this particular case, this is an example of a false negative, right? Which is an example here. So there's a one person where model is misclassifying that he is not sick but is a dangerous disease, but in the actual case he is positive. So this is a very dangerous case because that person will go out and spread the infectious disease, right? So the cost of false negative in this particular case is very, very high. Let's consider another example where the case of positive means a person is terrorist or not. Okay, if the actual person is terrorist and if the model is misclassifying as not a terrorist, again that's a huge cost, right? So that is again that will not be detected by this accuracy. Again, that's the case where there is a one false negative, which is the model is predicting as negative, but it's actually positive, right? So that's a false negative example. So it's a cost of false negative is very, very high. So in this particular case example, is cost of false negative is very high. Consider another example where cost of false positive is very high, where the model is saying it's positive, but it's actually negative. For example, let's say consider a case of spam email classifications where the model is saying that it's a spam, but in actuality it's not a spam. So you might lose some good emails, right? So their cost of false positive is very high. So that's why the accuracy does not take into consideration the cost of false positive and false negatives. That's why we need additional metrics like recall, precision, and F1 score. So accuracy, it's pretty simple, right? Just a ratio of true positive plus true negatives divided by total, and which is high in this particular case, but it's not good enough. So we go to the other metrics called recall. So recall gives us strength. It tells us how bad our false negatives are. So it's a ratio of true positive divided by true positive plus false negative. And in this particular example, it happens to be 50%, which is pretty bad. Ideally, it should be 100%, right? So this is an example where cost of false negative is very high. So like cases like we saw, like detecting sick person as not a sick person, or detecting terrorist as not a terrorist. That's the cost where the recall is very high, and it might be bad. So we need to make sure that in addition to accuracy, our recall is also high in cases where cost of false negative could be high. Another metric that we use is precision, which tells us the cost of false positives, which we should be 0 ideally. But if they were not 0, then precision will tell you how bad it is. So precision is a ratio of true positive divided by true positive plus false positive. In this case happens to be 100%, which is pretty good. So in this particular example that we saw, our precision was good, accuracy was good, but recall was bad, and that's why overall our models is bad, because recall also should be pretty good. Sometimes when we do not know whether the cost of false positive or false negative that should be optimized, we use a harmonic mean, which is the F1 score, which is the harmonic mean between precision and recall, and this is the formula. F1 score is equal to 2 into precision into recall divided by precision plus recall, and in this case happens to be 66%, which is not that great. So ideally it should be closer to 100%. Okay, so that time we try to just optimize the F1 score. So these are the metrics that we should consider. So whenever you're evaluating a model, don't just consider a case of false positive or accuracy. You need to take into consideration accuracy, precision, recall, and F1 score.